So for our example, we're going to look at converting the following angle measures from degrees to radians or radians to degrees as necessary, where we have the measures 45 degrees, 120 degrees, pi over 6 radians, and 5 pi over 4 radians. So for our first cases, going from degrees to radians, if we have that measurement 45 degrees, we can use one of math's greatest, and for people who don't have experience with it, most frustrating tricks, and say that 45 degrees is equal to 45 degrees times 1. Hooray! We've done nothing. You're going to find, especially when you get onto Calculus 2, that in math, a lot of times our goal is to do nothing in a way that causes an unexpected effect. Where here, 1, cool, happens to be importantly equal to pi radians over 180 degrees. So 45 degrees is equal to 45 degrees times pi radians over 180 degrees. And here, the degrees will cancel, and that 45 is going to go into the 180 a couple of times, and what we're going to get is pi over 4 radians. So 45 degrees is the same as pi over 4 radians, or as some will say, pi fourths radians. Whether you say one or the other, it means the same thing. But I was always used to saying it the first way. Either works. In any case, that's what we get for the first case. For the second one, it's the same idea. We're going to take 120 degrees and multiply it by 1 in a very creative way. So we have 120 degrees multiplied by pi radians divided by 180 degrees. And in this case, degrees still cancel. We've got pi radians, 180 under 120 is equal to 2 pi over 3 radians. And then in the other cases, we're doing the same thing, but we're going to think of 1 in a different way. So for the first one, we have pi over 6 radians, or pi sixths radians, although I probably wouldn't say it that way just because it sounds weird to put that many THs next to each other. And we're going to take that pi sixths, pi over 6 radians, and multiply it by 1, but written in a more useful way here, because we want to cancel out those radians and get degrees. So we have this, and we're going to multiply it by 180 degrees over pi radians. Now, pi's will cancel, radians will cancel, and we get 180 degrees over 6, or 30 degrees overall. And then, for our last case, we have 5 pi over 4 radians. Well, multiply by 1 again. We still have 5 pi over 4 radians, but now we're going to try and kill both the radians and the pi, which sounds very dramatic, but sometimes math is very dramatic. In this case, we're going to succeed. Pi and radians hits pi and radians, so we have no more of either. And we're left with 5 fourths times 180 degrees, which simplifies down to 225 degrees, illustrating that connection in the other direction. And I'll say here that generally when we talk about angles in terms of radians, we use pi's, and we talk about angles in terms of degrees, we use round, simple numbers, but technically speaking, if I feel like being weird or tricky, I could go the other way. I could say that we have an angle measurement of 3 radians, and we should understand that 3 radians isn't an angle of 3 degrees or 3 full radial rotations. It's actually just very close to being pi radians. It's a little bit smaller than that, but it's going to be close to a half rotation. By the same coin, if we talk about taking something in terms of pi degrees, that's really about 3 degrees. So it's a very shallow rotation. It's important to bear that in mind. Very, very rarely am I going to be mean-spirited enough to give you measurements in those terms, but understand that it can happen. It's just usually, if we're going to talk about radians, we're going to talk about them in the terms that make sense, and if we're going to talk about degrees, we'll talk about those in the terms that make sense. But know that that's not a hard and fast rule that we have to. And from this example, we have a few key measurements that we can talk about, a few important relationships in terms of revolutions and angles that have specific connections, as there are some nice important patterns that we'll see more of when we get into trigonometry in the next section that build towards a construction called the unit circle.